So now we're going to talk about the cerebellum. The cerebellum is the third part of the brain. It consists of an area in the posterior aspect of the brain, and if you look at it, it's definitely separated from the cerebrum right here. This is the brainstem, so it's posterior to the brainstem, and this is the fourth ventricle, so it's posterior to the fourth ventricle, and then is the cerebellum. It has two hemispheres, and it has gray matter on the outside with white tracks going all through it. The outside is the cerebellar cortex, and the white matter on the inside does have nuclei in it. They're called cerebellar nuclei. It does attach to the brainstem through the cerebellar peduncles. Now, what does it actually do? Okay, it actually functions in coordination. It takes what it knows of where we are in time and space and coordinates it with what the cerebrum is telling it. So it compares information from the cerebrum to what is really happening as it's getting messages from the muscles, the joints, the visual, and equilibrium receptors. The visual are what we see in our eyes, and the auditory or the equilibrium receptors are in our ears. And it compares all that information with what the cerebrum wants to accomplish. It coordinates complex muscle contractions, such as doing things that are very complicated. It helps coordinate all of that. Plus, it does things that we do not think about, like regulates posture and balance. People that have damage in this obviously would not be very coordinated, and it also alcohol mimics damage in these areas because of it infects it inhibits the the coordination that the cerebellum does with the cerebrum. This is called ataxia, which is a lack of muscle coordination. People can't walk a straight line. They can't close their eyes and touch their nose. They have trouble speaking because the tongue is a muscle. And think of how complex language is itself just with all the muscles to form the words. And then you can have an abnormal walking gait. They call it an ataxia when you have this abnormal walking gait. And it has to do with not being able to judge the distance from your foot to the ground itself. So you tend to hit the ground very flat-footed, and it's a very slapping gait, so it's very loud. And sometimes you may have seen somebody walk like that, sometimes not. But anyway, try walking flat-footed without heel-toe movement, and that's an ataxic gait. Okay, I'm going to go ahead and cover part of the cerebrum right now because we're through with the cerebellum, and I have a few minutes. So we're going to look at the cerebrum. This is the cerebrum, and you can see that we have gray matter on the outside. It has two hemispheres totally separated from each other. So this is the actual right hemisphere right here. This is the gray matter on the outside. And it has different lobes also we're going to talk about later. Okay, so the cerebral cortex, gray matter, inside white tracks with areas of nuclei. And these nuclei are called basal ganglia. Like I said, this is saying what the nuclei are, but you should know that it's the cell bodies and the dendrites and unmyelinated axons. So what does it do? It tells muscles when to initiate contraction and terminate contraction. It also helps regulate muscle tone. So people that have damage in this area have uncontrollable shaking, they have stiffness, and involuntary movement. Also, it helps with what we do subconsciously as far as movements go, like whenever you think about people walking, how they hold their arms, or when they're running, how they hold their arms. That is part of what the basal ganglia does. Now, the main part of the cerebrum, all of this hemisphere right here, functions in reading, writing, speaking, thinking, planning. It's our Tom thinker. If it's not just pushing a button, it tells us what to do, and it makes us think about things, makes us be logical, things like that. Okay. It has a lot of landmarks on it and everything, so we're going to talk about that in the next video. See you guys later.